Today's video I would like to introduce you a very nice problem of Bulgarian Mathematical Olympiad edition 1998. Here is the following information. Suppose m and n as natural numbers such that we have this setup. Capital A equals m plus 3 to the n plus 1 is divided by 3 times m, okay, is an integer. So the question is very clear. We are going to prove this number must be odd. I'm not going to give any hints to this problem because it's straightforward question and the information are very limited here, okay. I would be recommend to give it a try to this problem prior getting to the solution. Go ahead, pause this video. When we come back to see the full solution. Now let's get started. We have this term as follows. Capital A equals m plus number 3 is raised to the power n plus number 1 is divided by 3 times is multiplied by m, okay. This one is an odd integer. So this is our goal. We are going to prove this one is an odd integer, okay. That's mean 3m divides the numerator and also the result found must be odd term, okay. So we are not going to work on n, we are going to work on m because n is located at exponents, so it's not going to help us to find the parity of the whole system, okay, because any whether is odd or even is not going to change anything here, but m if is odd or even it can change the whole thing, okay. So that's our goal. We are going to check when we have m is an odd number and when we have m is an even number. So if m is an odd, this is very straightforward case. If m is an odd, that's merely be written on this form. M equals 2k plus 1, okay. So I'm going to insert this value into this setup. We'll have capital A equals 2k plus 1 plus 3 to the n plus 1 is divided by 3 is multiplied by 2k plus 1. I'm going to simplify this one is given as 2k plus 4, okay. So I'm going to take number 2 as a common factor. I will have 2 here. I will have k plus 2, okay. I'm going to take this number 2 out of these things. I will get 2 to the n is multiplied by k plus 2 to the n plus number 1 is divided by 3 is multiplied by 2k plus number 1, okay. This is even because we have number 2 as a power plus number 1 become odd. This is the whole thing is odd. This one also is odd. That's mean capital A is a odd, because if you have odd in numerator and odd in denominator, so the whole thing must be odd. We are okay to go now. If m is an even. Before we prove this one, I'm going to remind you about the binomial expansion. So if you have 1 plus x to the n, I'm going to expand this one. This one is given as 1 plus n is multiplied by x plus n is multiplied by n minus 1 over 2 factorial is multiplied by x squared plus n is multiplied by n minus 1 is multiplied by n minus 2 is divided by 3 factorial is multiplied by x cubed and so on and so forth, okay. If I'm going to take, for example, m equals to k as an even number and insert it into this setup by using this binomial expansion, is given as 2k plus 3 to the n plus 1 is divided by 6k, okay. By using this binomial expansion with this number 1, again I go with this number 1 become even, and do you take number 2 out of this box as a common multiplier and divide by denominator, so the 6 will be cancelled out, become 3k, right. In the denominator become number 1 because after you simplify with number 2 here. So the problem, you will have the problem with this term. This term is fine because this term has the power of 2, okay. That's fine. This from here to here, all that is even. All the rest is even. But the problem with this product is not going to help because we don't know the parity of this product. Okay. Even though if you are going to check m equals 4k, you will find the problem also. Okay. Because when you take m equals 4k and insert it into the setup, you will have 4k plus 3. Okay. Then you split this term into two parts. You get number 2 plus 1. Plus 1 will be expressed as this form because you are going to apply the binomial expansion here. So then you take number 2 as a common factor because we will have 4k plus 2. So we'll have 2 is multiplied by 2k plus 1. And then after simplification, and then in the denominator, you will have 3 is multiplied by 4k, we will have 12k. You need to cancel out number 4 from numerator and denominator in order to get the parity. Okay. But when you try to cancel out the numerator and denominator, you will find also the problem with this product. Okay. The problem of you don't know the parity of n. Okay. I'm going to erase this one and pick up another value of m in order to get us to the solution. Okay. Now if m is even, I'm going to choose m equals 4k minus 2. Okay. Since we have m and n are natural numbers, that means m start with number 1 and up. So we'll have a capital A equals m will be replaced with this value 4k minus 2 plus 3 to the n plus number 1 is divided, I will get 3 is multiplied by 4k minus 2. I'm going to simplify this one out. I will get here number 1 plus 4k to the n plus number 1 at the end is divided. I'm going to take number 2 out of this parenthesis. I will get number 2 here is multiplied by 3 is multiplied by 2k minus 1. Okay. Now I'm going to apply binomial expansion here as I did in the previous example. So I will have capital A equals number 1 plus 4n is multiplied by k as a second term plus n is multiplied by n minus 1 over 2 factorial is multiplied, we'll get 4 square is multiplied by k square plus the fourth term, which is n is multiplied by n minus 1 is multiplied by n minus 2 over 3 factorial is multiplied by 4 cubed is multiplied by q cubed and so on and so forth. Okay. Here plus number 1 at the end plus number 1 at the end, this one, the original one. The whole thing is divided by this term 2 is multiplied by 3 to k minus 1. Okay. Now I'm going to take this number 1 and this number 1 and putting them together. I will get become number 2 here. This one will be cancelled out. Then I'm going to take number 2 as a common factor. I will have number 2 here is multiplied by number 1 plus 2nk plus this one. This one is a even. This one is a even because we will have 4 square here. Okay. Plus even number. Because we don't need to write the whole expression here. This is, we know this is one is a even because we have 4 square here. Okay. Then is divided by this term 2 is multiplied by 3 is multiplied by 2 k minus 1. Okay. Now number 2 will be cancelled out from numerator and denominator. Then this term now is a odd because this term is a even plus even is given as even plus odd is given as odd. The denominator is a odd. Since this one is a odd is multiplied by odd is given as odd. So that means that odd is divided by odd is always odd. This one must be odd. Okay. So in both cases we found this capital A is an odd number. And don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.